this plant, it's the backwards one, it doesn't have the blue light response, it only has red light response. So, again, something different, but yet, both of these species of plant, both these, this genus and this species of plant, it works. You know, you don't need both of those responses, obviously, to make a plant, but most plants have both. Zeaxanthan, this is under consideration, but that's what I had. CO2 concentration, the general response. High CO2 concentrations, the stomata tend to close. Low CO2 concentrations, they tend to open. Why is that? Well, if you have a certain amount of photosynthetic enzymes in the leaf, you can do so much photosynthesis. The photosynthetic rate is limited by how much of those enzymes you have and the supply of CO2 to those enzymes, right? If the CO2 concentration goes way up, eventually you're going to be saturated and you're not going to increase your rate of photosynthesis anymore because you just don't have the enzymatic machinery to deal with it. So under very high CO2 concentrations, it makes sense for the plant to decrease the stomatal conductance and lose less water while still maintaining that photosynthetic rate. That's a smart examples. The important consideration is the internal CO2 concentration. But if you look at a cross-section of the leaf, so here's the epidermal layer with cells here, here's the bottom of the leaf, and then you come to a pair of guard cells in the epidermis. It's been shown that this surface of the guard cell is permeable to CO2. Not this surface, not this surface. It's this inner surface that's exposed to the airspace inside the leaf that's permeable to CO2, and presumably then that's the CO2 concentration that the guard cells are responding to, the internal CO2 concentration. Since we can't directly measure it, we have to estimate it using gas exchange. Plants, in many situations, plants tend to regulate their stomatal conductance so as to keep the ratio of Ca to Ci constant. And for C4 plants, that ratio is about, Ci is about 0.4, Ca in C3 plants, it's about 0.7. The difference comes about because C3s have appreciable photorespiration, C4s don't. That leads to differences in water use efficiency, and here are these values for C3 plants, 1 to 3 grams of CO2 per 1,000 grams of water lost. C4 plants, slightly more efficient, 2 to 5 grams of CO2 per 1,000 grams of water lost. And CAM plants, most efficient of all, 10 to 40 grams of CO2 per 1,000 grams of water lost. This is averaged over a day. Those are values that here's this ratio. It's not always constant.